Hi, today is 17th July 2020 and from today exactly 133 days are remaining for CAT 2020 and today I'm going to discuss two questions from permutation and combination. So you all can pause the video and try to solve both the questions. Alright, now it says call a 7-digit number D1, D2, D3, D4, D5, D6, D7 memorable if the prefix sequence D1, D2, D3 is exactly the same as either of the sequence D4, D5, D6 or D5, D6, D7 or possibly both. Assuming that each DI can be any of the 10 decimal digits 0 to 9, find the number of different memorable telephone numbers. Alright, so basically it's a 7-digit number. So I'll say the 7-digit number is D1, D2, D3 and then followed by D4, D5, D6 and D7. Now first case we'll consider when D1, D2, D3 is exactly equal to D4, D5, D6. Okay. So what are the possibilities? The D1, it can be any of the 10 numbers from 0 to 10. D2 can be any numbers from 0 to 10 and D3 can be any number from 0 to 10. So 10 into 10 into 10 that is equal to nothing but that is 1000 here. Alright, so that is 1000 here. So similarly for here, so this is 1000 choice. So if there is 1000 choice, the same number is going to appear. And for D7, D7 can be also any number from 0 to 10, so in 10 ways. So how many cases are there in which D1, D2, D3 is exactly same as D4, D5, D6? I can say the total number of cases is 1000 into 10 here. Similarly, another case if I say D1, D2, D3 and then D4, D5, D6, D7. If I say D1, D2, D3 is equal to D5, D6, 7. So for example, D1 has got 10 choices, D2 has also got 10 choices, so D3 has got also 10 choices. So 1000 choices. Alright. So the same number will automatically will come at D5, D6, 7. Remember, we cannot say again another 1000. Like if D1 is equal to 1, so D5 has to be 1. If D2 equal to 2, so D6 has to be equal to 2. So if D3 is equal to, let's say again 2, D7 also it has to be equal to 2. So for every 1000 choices for D1, D2, D3, there is exactly one choice for D5, D6, D7. And same thing in the previous one. Exactly one choice for D4, D5, D6 also. But for D4, there is no restriction. So D4 can take any 10 numbers. So how many cases are there in which D1, D2, D3, it is equal to D5, D6, D7. Again, that is 1000 into 10. But there can be case where the few numbers are common to both of them, isn't it? That D1, D2, D3 is equal to D4, D5, D6 as well as D5, D6, D7. So I need to check in how many of the cases D1, D2, D3 it is equal to D4, D5, D6 and it is also equal to I can say D5, D6, D7. Why? Because these cases are counted in both the cases. So there is a double counting and we need to avoid that. Alright. So how many cases are possible here? Now this sequence is only possible here. It is only possible if all the digits are same. Like this is 111, this is also 111 and this is also 111. Or maybe all the digits are nothing but that is 222, 222 and 222 here. So and so on till I can say 999, 999 and 999. And also we can take the number as 0 also. 0 is also allowed. So how many cases are there in which all these sequences are equal like D1, D2, D3 is equal to D4, D5, D6 as well as D5, D6, D7. So there are total of 10 cases here. So there are 10 numbers which is counted in both the cases here. So what is the answer? The correct answer will be 1000 into 10 plus 1000 into 10 and minus 10 here. Why I have subtracted 10? Because these are the 10 cases which is counted in both the cases. Or I can say, let's say if this is set A and this is set B. So this is nothing but that is A intersection B. And we need to find out A union B. Okay, to avoid the double counting. So that will be equal to A plus B minus A intersection B. So this is what I have done here. So if you solve this, it will be comes out to be how much? 19,900. So the correct answer for this question is 19,900. So I hope that this is clear to all of you. Now, let's move to the next question. Now, this question says, okay, how many three-digit numbers satisfy the property that the middle digit is the average of first and last digit? Okay, so middle digit is the average of first and last digit. So let's say here, if I say the numbers are A, B, C, and middle digit here is B, and it is the average of first and last, so that is equal to A plus C by 2. So this implies 2B, it must be equal to A plus C. Now what about 2B? 2B is nothing but, it is nothing but always an even number. Now A plus C, the sum of the two number is even. That is only possible when A is also an even number, C is also an even number. Or A is an odd number and C is also an odd number. Because the sum of two odd number is also even, as well as sum of two even number is also even here. Now, let's try and identify how many cases are there. When A and C, both the numbers are odd. A is odd and C is odd. How many cases are possible? A can take any number, either 1 or 3 or 5 or 7 or 9. Remember, A, B, C, all of them are single digit number. And similarly, C has also 5 possibilities, 1, 3, 5, 7, 9. So 5 into 5, that is 25 cases. So there are total of 25 cases in which both the numbers are odd. Now, how many cases are there in which both are even? Like A is also an even number as well as C is also an even number. Let's say, now, if A is an even number, what are the possibilities? The possibilities are A can be either 2 or 4 or 6 or 8. Now, remember the digit is ABC. So, A, the leading digit, A can't be equal to 0. Okay. So, A can be 2, 4, 6, 8. But what about C? C can be anything, any even number, 0, 2, 4, 6, 8. So, how many cases are possible? 4 into 5, which is equal to 20. So there are 20 cases in which A and C are even and 25 cases in which A and C are odd. And you'll get B automatically. So what is the answer? That is 25 plus 20. And 25 plus 20 is equal to 45. So the correct answer of this question is 45 here. So I hope that this is clear to all of you. So that's all for today. All right. Thank you.